Great talk, Gio. I really enjoyed that. I think that the history of science illuminates very well what you're talking about. In the 17th century, for example, the premier science was physics, and its most outstanding success was in mechanics. The breakthroughs of, say, Galileo and Newton and their successors was the spectacular success of their project of finding a precise language to describe and test and predict observations. That language, of course, was mathematics. The Greeks had reached a brick wall, essentially, 1500 years earlier, when they tried to describe motion and change mathematically, in particular geometrically, because they thought that infinity was such a repugnant idea in analysis, and they couldn't describe motion or any change in a way that didn't involve an infinite number of infinitesimal states, all incrementally different. It took Newton and Leibniz to invent a mathematical tool, differential calculus, to describe motion properly and get physics moving again. In addition, the brilliant success of mathematical descriptions in other fields, such as optics and physical chemistry in the late 18th century and 19th century, became the gold standard that all would-be sciences would need to emulate if they were to be taken seriously. The mathematics was usually linear algebra or coordinate geometry, but progress could be made with non-linear relationships by a simple mathematical transformation that reduced them to linear ones. And the other trick used was to simplify systems by ignoring non-linear effects, because they were so often so tiny that they could be overlooked. For example, in Boyle's law, the gas laws relating pressure and temperature and volume of a gas, they work perfectly well with the fiction that gas particles were dimensionless. The error in this assumption was negligible. The same with the physics of the pendulum. But by the end of the 19th century, physics had built up quite a pile of incommensurables, things that didn't quite fit. To some, like Lord Kelvin, these were minor annoyances. He famously said in the last years of the 19th century that there was nothing new to be discovered in physics now. All that remained was more precise measurement. But when Einstein and others dug into these minor issues, they uncovered a mess, and that required the rewriting of physics and revealed an undreamed of complexity that has grown even more so in the last century. And it has demanded a new level of sophistication in mathematics to describe it, and in philosophy to understand. Physics got a firm kick out of the linear reductionist realm, but the 19th century linear reductionist physics had cast a dominating shadow over all scientific endeavour because it was so spectacularly successful. And other disciplines, for example, the human sciences of psychology and sociology, economics, as they tried to become respectable and distance themselves from metaphysics, tried to use the same sort of mechanistic models that had been so successful for physics. But these fields, and also systems like climate science, ecology, medicine, population science, were far more complex because they had so many more variables. They were multivariate and unisolatable. That's why they have never been so successful as a predictive tool as physics was. And the current economic failure is partly due to placing undue confidence, the confidence that physics typically enjoys, in economic linear transforms. It's only been since the computer has been available as an analytic tool that the study of complex systems has really taken off. The calculation burden of multivariate systems is formidable. As a simple example of that, the Mandelbrot set was only discovered when computers had the computational grunt to calculate each of the millions of pixels in the complex number plane. It's not a hard job to calculate one pixel, but no one would do it for millions of points. And there's no equation to predict what the value of any pixel will converge to. You have to test it individually. I wonder if our problem with linear thinking is that we, as humans, of what Richard Dawkins calls middle world, is a world that is not too big, not cosmological, and not too small, not quantum, but middle. In our world, our middle world, Euclidean geometry still holds, and straight lines are straight. in this world we are predisposed to think linearly. For example, we do it all the time. If 1 drink is good, then 2 will be better, and 3 will be better still. And the same with medicine. Take more pills for a bigger cure, or consider various degrees as unique entities rather than embedded in a complex of body, spirit, community and environment. Hit a kid harder to punish a greater transgression, build bigger bombs to scare off a greater threat. We seem to have a lot of difficulty breaking away from this simplistic way of thinking. There's a frightening and dangerous linearity in so-called common sense thinking. But thankfully, we can think beyond common sense. Surely that's one of the lessons we learn in the 20th century. That the top-down dominating masculine energy of analysis is typically reductive. It involves a simplification of systems by averaging out the particular in order to find a simple description of the general. This means that the importance of small outliers is often missed. The famous butterfly wing that tips the balance and a cause and effect chain that ends with a hurricane halfway around the world. This requires a bottom-up view. It's synthetic, relational, feminine, if you like. More humane, and it's desperately needed, as you say, Gia. I strongly recommend the neuroscientists' talk, Jill Bolte-Taylor, on left-right brain. She discovered the 2 contrasting processing modes as a lived experience in her own life after she had a stroke. In fact, while she was having the stroke. Her analytical left hemisphere was knocked out by a bleed, and her synthetic global right hemisphere was left to run the brain. And her insights have got a lot to say about the nature of enlightenment as a rebalancing or turning down of the left hemisphere and a turning up of the right hemisphere. The left is about words, analysis, narrative, third-person objectivity, and the right is about relational, aesthetic, spiritual, first-person, subjective perspectives. And I suspect that it's of seminal importance in understanding the nature of, for want of a better word, spirituality. It's on my favourite list anyhow, so check it out if you haven't seen it. Thanks.